this experiment, I will be able to carry out a test on solution Q to identify the cations and the anions present in this compound. So in order to do this, I've got a guide, some questions that I'm supposed to answer. So these are the questions that I'm going to answer. So if you have got, you can pause this video and then try to go through these questions so that we go through these questions together. So in this experiment, the apparatus that I'm going to use consists of these 4 test tubes. Then I've got different solutions. There is this is silver nitrate. Then this is solution Q, which happens to be copper 2 sulfate. Then I have, this is ammonia, aqueous ammonia, of course. Then there is aqueous sodium hydroxide solution, and then there is also this barium nitrate. So to start, the first question in here states that we should add, or the first procedure, it states that we should add about 2 cubic centimeters of solution Q, and this is solution Q. So what I'm going to use this dropper, and make sure that this dropper, once it is used in this solution, is just supposed to be placed in the, or put back in the same solution. You should not change the droppers. So this is about 2 cubic centimeters of solution Q. And then the next thing I'm going to do is to add few drops of sodium hydroxide. So these are the few drops of sodium hydroxide. We need to get the few drops of sodium hydroxide, and in this case I can recommend that just 3 drops are enough. Don't add more. So one, remember to shake 2, then also 3. So these are the drops. So as you can see in this, you can see that certain things have been formed, some crystals. I can see some crystals that are being formed, and also the color itself. So now, how do you get the color nicely? So what we are going to do is that you need to have a guide with you, and every practical under qualitative analysis, there is a paper that we use, which we call notes for use in qualitative analysis. So this experiment, since it is based on a qualitative analysis, then you are supposed to use this part of a paper, so that it is able to guide you on the answers. So what I'm going to do is, now I have to look at sodium hydroxide under cations. Under cations. So under cations we have copper 2 sulfate here, and according to my observation, you can see here this is light blue. So since it is light blue, and light blue, I've seen that there are certain things that have been formed, which are some solid particles. They look like solid particles. So these are what we call the PPT. Okay. So that's one observation under carbocation, and since it has come out in this case, it means that the carbocations have been identified already. Then we have to add more or excess of sodium hydroxide. So when we add excess sodium hydroxide, have you seen the color has just changed instantly? So you can try to shake and see that the color has changed, and this color change is blue, dark blue, and because it is dark blue, and it shows that this is insoluble. So sodium hydroxide, when it is added into copper 2 sulfate in excess, it is insoluble. It is insoluble in excess, while when it is added in fuel, it forms a light blue PPT. Okay. Then the next thing I'm going to do is to add the same amount. Now this time I need to use a different test tube. So I'm adding copper 2 sulfate in a different test tube. So what I'll do now is to add a few drops of aqueous ammonia. So this is aqueous ammonia. So what you do is you get aqueous ammonia. So I'm going to add aqueous ammonia there. A few drops. So I recommend 3 or 2. So 1, and you should shake a bit. So you've seen. So what we have found so far is that a precipitate has been formed. So this is light blue precipitate. So this is light blue precipitate. Okay. So now, having done this, then I'm going now to add. You've seen there are 2 different colors here. Okay, there are 2 different colors. So this is the light blue precipitate and this is the dark blue. So what I'm going to do now is to add more or excess ammonia. So when you add excess, as you see, I mean this is the dark blue ammonia, and this one so shows that in excess ammonia is soluble in excess when it is added to copper 2 sulfate solution. Okay, this is what it shows. So the next thing that I'm going to do now is to add again the these are the results that we are getting. So this is for the ammonia. So what I'm going to do now is to add in a different test tube. So I'm adding about 2 cubic centimeters of copper 2 sulfate, and then second I'm going to add equal volume of acidified silver nitrate. Now this is acidified silver nitrate here, so I'm going just to get some equal volume of acidified nitrate. The whole of this quantity should be added there, and then I need to observe what happens. So this is it. So you need to shake every time that you add solutions or you mix solutions in test tubes. You need to shake. So I've shaked, and as you can see, this is a clear solution. Of course, this is a clear solution. So when acidified silver nitrate is added to copper 2 sulfate solution, it forms a clear solution. Okay. So once you use these solutions, make sure that they are put aside to reduce congestion and also some access. Okay. So what is remaining with? What I'm remaining with is to add about 2 cubic centimeters of copper 2 sulfate in one of the beakers. So I've added, and then I need also to add the same amount of volume, which is 2 cubic centimeters of barium nitrate, and then we see what happens in the next stage. So this is barium nitrate. Okay, this is barium nitrate. So this is barium nitrate, and I'm going to add the same amount, and then you see what has happened there is that the solutions has turned milky. The solution has turned milky after adding barium nitrate. So you can see these solutions. Now the thing is, since we have this guide here, I know we have just used it once. So now it is time now we can use it to answer the questions that are here. Remember, there are questions down there. You can see these questions here. So these are the questions that we are going to find. So the first question here says, name the cation present in this compound. Name the cation present in this compound. Okay. So the cation present in this solution Q is no other than we go to the cation table, and under the cation table you can check which of the solutions do we use. So we never used aluminium, we never used also ammonia, we never used calcium, we never used iron 2, 3, and also zinc. So what you used here under the cations is copper. So what the presence, in this solution, it means that there is a presence of copper 2 ions. So those are the things, that is one thing that we have to understand. Okay. The next thing that we have to understand is the other question is write the formula of the anion present in solution Q. Same procedure, you have to go to the table where it says anion, you use elimination method. So here you need to check, did we use And our solution. Did we have solutions that any solution with the carbonate solution? We never had that. We never used chlorine. We never used iodine. We never used nitrate. But what we used is a sulfate. So what we are going to do now is, how do you understand that? You go to where there is acidified barium nitrate. That's the one we used. So this is, and it formed white PPT. This is the white PPT that it formed. You can check. This is the white PPT it formed. So this is guiding us. Now that we have identified this, so meaning that we are going to write sulfate. Just sulfate is enough. Then the second question is, which test number was used to identify the anion in Q? So which test question or which test number? So now when you look at this, you will find that here what we have done is we added about 2 cubic centimeters of barium nitrate, copper 2 sulfate, and then we mix it with 2 cubic centimeters of barium nitrate. And what did we observe? We observed that we had the white PPT. So this white PPT was it is an indication or identification of the anion present. And this anion that is present is according to where there's white PPT, it is barium nitrate, and this barium nitrate is a D. So you can see this is where the D is. The D is here. So this is the test number D. That's the test that gave us a white PPT after that reaction. Thank you. Now, away from this one, write the chemical formula of the compound. Now, the compound in this case is made up of different elements. So which different elements have we found? The different elements in this solution we have found is copper 2 sulfate, and also that's the copper 2 sulfate. So those are that is what we have found in in the solution. So thank you very much for watching this demonstration of how to find the qualitative analysis using solution Q. Otherwise, all what you need to do is to subscribe to my YouTube channel and also like my Facebook page. Thank you very much. Bye-bye.